Hi team, let's see about the ICP6. So the main objective of ICP6 to use the existing given autoencoders model and add hidden layers and see the accuracy, plot the accuracy loss, and also visualize the input images to the reconstructed images from the encoder, and doing the same thing for the denoising autoencoder. Yeah, let's see the demo part. Yeah, the first I have imported the necessary libraries over here. The Keras and the Matplotlib are the most necessary one over in this for this objective, and the loading the fashion MINST data set. So I'm splitting the test and train. So basically the test has doesn't for this objective the test has no impact, so just the train would be necessary. So converting it to 255, dividing it by 255 to normalize the train data and reshaping it to get into a single feature vector. So here this is the where I'm building the model. So apart from the encoder decoded, we have adding, and to the input layer we have added one hidden layer towards the encoded and one hidden layer towards the decoded layer. So the activation which we used are ReLU, and for the output layer we have used activation of sigmoid. And for the compile we had to use metrics to plot the accuracy and loss. So this is where I'm fitting it to the model. So I have taken 10 epochs and batches of 256. Here the main thing we need to observe is we need to fit with extrain and extrain, as it is not a labeled data, and we have taken a fashion minus data set which is categorized. So we have given as an extrain and extrain as the image which we are fitting, and also the output should be the same image. So that's why we are fitting with same values, extrain and extrain. So that's what we can observe from this extrain. So fit. So this is the 10 epochs. So here I've taken the first 10 images and I plotted the images versus the original images versus the reconstructed images. So this is how it looks like. And on the model.fit I given to one variable called history. So I've given 10 epochs, so the each history is divided into 10 epochs. So if you see the val accuracy as 10, val loss as 10, loss and accuracy are 10. So taking the values from this I have plotted the accuracy and loss functions. So here it is. So as I've taken 10 epochs, it is as I've taken 10 epochs. On the x-axis we have 10, and the y is accuracy. As the number of epochs decreases, we can see the changes in the accuracy. In the same thing it goes with the loss as well. Yeah, now let's see the same thing for the denoising data. So here it's as well importing the necessary libraries, Keras and Matplotlib, and splitting the data, loading the fashion minus data and reshaping it and dividing it to 255 to normalize it and reshaping it to single feature vector to the existing model. And we are before building the model we need to introduce the noise. So noise is the thing which controls the noisiness between among the data. So here we are also saying that the scale is between the 0 and 1 to make sure that the values are always are in the same range and standardized format. So to the given next train and test we would be introducing the noise factor. Once the noise is introduced, then we would be building the model. So here as well the activation we have used ReLU, but the final layer we have used activation as sigmoid, and the metric is accuracy. If we want to calculate if loss and accuracy. So fitting, we need to fit the extrain noise and the extrain as to know what is as the model should know difference between the train and the extrain noise. Epochs are given 10, the batch size is 256. And the validation is it's same X test and X test noise, as there is no Y test, as there is as it is not a categorical data, and it has no impact having the Y test noise. So that's why we would be giving X test and X test noise, as it is unsupervised learning. And we are plotting taking the first 10 images, and we have plotted the images for the original images and the images which are reconstructed and the noisy images. So this is how it looks like. And also I plotted the accuracy and loss from the history attribute. Yeah, this is all about the ICP6. Thank you.